Here we have 3 points, P, Q, and R. Our task is to find the coordinates of the point S so that PQRS forms a parallelogram. A little sketch to help us. Let's draw a very rough parallelogram. Now when you're given the name of a parallelogram like we have here, PQRS, that is the points going around either clockwise or anti-clockwise going around the shape. So this could be labeled P there, Q there, in which case R would be here and S would be there. Another way it could have been labeled, on this one I went clockwise, could have gone anti-clockwise. That could be P, this could be Q, that could be R, and that could be S. It really doesn't matter. The sketch is still useful for what we're trying to do. So we know where P, Q, and R are. In other words, we know how to get from the origin to each of P, Q, and R. We just need to figure out where S is. Well, if it's a parallelogram, then opposite sides are the same length and they are also parallel. So if I let S equal something like the vector x, y, z, then I could work out QR, for example, and then I know from a diagram that would have to be exactly the same as the vector PS. Looking at my directions carefully, going from Q towards R, and then going in the same direction here. So going to the right would be the same as PS. The same direction, they're parallel, and they're exactly the same length as well. So something like this can be the key to unlocking this question. There's more than one way we can do this, but that's the way I'm going to approach it. This is what I'm going to do. I'm going to use the fact that PQ and SR must be exactly the same vector, and this is enough. This is a sufficient condition for PQRS to form a parallelogram. We don't need anything else. That will do. Let's work out PQ. We know where P is, we know where Q is. Make sure you do the position vector of Q, take away the position vector of P that way round. Don't get them the wrong way around. So there's PQ, 3, 2, minus 4. I'm going to call the position vector of S x, y, z, and then I'm going to work out S, R. So if you remember what I'm doing here, so this is P, Q, going around in order, P, Q, then R, then S. SR is this vector here, SR, and PQ from a diagram you can see must be exactly the same vector, same length, same direction. So this is SR, this is PQ, they have to be the same. In other words, 3 must equal 8 minus x, 2 must equal minus 2 minus y, and minus 4 must equal minus z. Solving each of those components, I get x is 5, y is minus 4, and z is 4, which gives us the coordinates of point S. Now, if the question says find the coordinates, then really you should give your answer in coordinate form like I've done here.